All right, so very good morning to all of you. Am I audible to you? Is my voice clear? Very good morning, all of you. Just let me know in the comment section if my voice is clear. Okay, right. Okay, I think everything is working fine. So let's start off with today's session. So this is our first question. Okay, so we already did two sessions on YouTube. So you can watch those sessions in case you have not watched those sessions yet. So this is the new session and we'll be practicing some more questions which are very important for your IIT JAM 2021 examination. Okay, so let's take very first question right there in front of your screen. So what is given in the question? Activation energy is given. So you have a reaction A giving B as product. So this is your reaction and activation energy for this reaction is given. Okay, it's 80 kilojoules per mole and heat of reaction is also given, that is 200 kilojoules per mole. Okay, what you need to find out? You need to find out activation energy for B giving A. So this is your first question. Okay, so Manish is going with 250 kilojoules per mole. Shaker says minus 120 kilojoules per mole. What about others? Yes, so what is your answer? Sanjana, Sonia, Atanu, Mosmi? Lovely, right? All of you. What is your answer for this question? Okay, 280 kilojoules per mole, all right. It's 80, right? This one is 80 kilojoules per mole. Activation energy of A to B is 80, not 50. Right, okay. So let's solve this question. So what all values have been given to you? You have activation energy of A giving B, okay? And you have heat of reaction, that is 200 kilojoules per mole, okay? So let's suppose, let's draw energy profile diagram. So this is your energy profile diagram. So this is your potential energy, right? And this axis represents your reaction coordinate. This axis represents your reaction coordinate. Okay, so any factor, any variable which changes with time in a reaction is known as your reaction coordinate, and this axis represents your potential energy, right? So now let's suppose this type of reaction we have, right? We are basically performing this type of reaction. Okay, so what is given to us? We have been given that this activation energy of forward reaction, that is A to B, is nothing but 80 kilojoules per mole. Okay, A to B is nothing but 80 kilojoules per mole. Okay, so what we have to find out, we have to find out activation energy for the reverse reaction. Okay, now if this activation energy is from A to B, then definitely this activation energy would be from B to A, right? Can I say this thing? This activation energy is from B to A, right? Now how I can calculate this activation energy? So activation energy of B to A, right, is equals to this value, okay, this value plus this value. Okay, this value is already given to us, that is 80 kilojoules per mole. Okay, so what we can write down, activation energy of AB plus delta H. Okay, that is your heat of reaction. So this value is already given, that is 80 kilojoules per mole, and this value is also given, that is 200. Okay, so correct answer for this question would be 200 kilojoules per mole, right? 280 kilojoules per mole. Is it clear to all of you? Any doubts? Is it clear? I hope this question is clear. So let's move on to the next one now. So what you have to find, right? So it's a planar structure. So what you have to assume, this is your planar structure. Okay, there is no flipping. Okay, there is no flexibility of this cyclohexane structure. So assuming this structure to be a planar structure, you have to calculate number of 1H NMR signals in one. Basically you have to calculate a number of 1H NMR signals if this structure is planar. Right, okay, see, in this question they have not mentioned the type of reaction. Okay, but yes, definitely with help of this information, we can say that this type of reaction is your endothermic reaction. Okay, because delta H is positive, right? Delta H is positive. But the question was, if this is your activation energy, that is 80 kilojoules per mole, and according to the statement it was written, the amount of heat of reaction released, okay, the amount of heat of reaction released is 200 kilojoules per mole. Okay, then this would be your correct answer. Okay, now if this word is not written, that is released, so you can assume that this type of reaction is your endothermic reaction. Okay, so in endothermic reaction this energy would be higher, so activation energy of AB, right, is equals to activation energy of BA plus delta H. Clear everyone? Okay, so just read the statements carefully. In this question, this amount of energy is heat of reaction released. Now it, right, it is basically making sense, heat of reaction released. Okay, so it's a genuine question, and I, right, basically I'm very happy that you are actually thinking on these type of questions. Okay, so this is amount of heat of energy released. All right, okay, so let's discuss this question. So it's a planar structure, okay? So, right, we are assuming that this is your planar structure and there is no flipping in the structure, okay? So now if this is your planar structure, we have to count number of 1H NMR signals, okay? So see, in this case, this is your above the plane methyl and this is below the plane methyl, okay? Now, if this is above the plane methyl and below the plane methyl, so what we can say, we have to find a basically relationship between these two methyls, okay? Or we can say that if this methyl is above the plane, so then there is one hydrogen, okay, which is below the plane, right? And if this methyl is below the plane, then there is one hydrogen which is above the plane. Can I say this thing? There is one hydrogen below the plane and one hydrogen above the plane, okay? So if I have to calculate, right, the number of signals, so there are two hydrogens over here, okay, right? So there are two hydrogens, and what is relationship of these two hydrogens? Anyone? What is the relationship of these two hydrogens? The one which basically I wrote in blue ink. What is the relationship between these two hydrogens? Right, okay, so these two hydrogens are basically diastereotopic. How they are diastereotopic? See, this carbon, right? This carbon is basically this particular carbon, okay? This is a chiral center, and this carbon is also a chiral center, okay? See, the molecule is like this. This is above the plane, and this is below the plane, okay? So if molecule is like this, so there is no C2 axis in the molecule, right? There is no C2 axis in the molecule. See, what we can actually see, that definitely there's a C2 axis over here, okay? So there's a C2 axis in this molecule, but if I'm taking these two hydrogens into consideration, this one, okay? So let's draw this molecule again. Right, okay, so this is above the plane C2, this methyl is above the plane and this methyl is below the plane, okay? So now I have to find relationship between these two hydrogens, so let's name it as 1 and 2, okay? So definitely there's a C2 axis present in the molecule, but these hydrogens are not reflecting, okay? Yes, C2 axis is there, but these hydrogens are not reflecting, okay? We have to find the relationship of these hydrogens, but these hydrogens are basically not right replaced they are not replacing each other position, okay? So if these two hydrogens are not replacing each other position, so that means they are not homotopic, okay? They are not homotopic, okay? If I have to check the enantiotopic relationship, then this type of plane of symmetry is not possible. This type of plane of symmetry is not present. This means, okay, they are not even enantiotopic, okay? They are not even enantiotopic. Now let's go to the diastereomeric relationship. So if they are not enantiotopic, okay, and these two are your chiral centers, so definitely these two are your diastereotopic protons, okay? Now if these two are diastereotopic protons, so they will give you right, one or two signal. They will give you one or two signal. If they are diastereotopic, so they will give you one signal or two signals. Right, okay, so they will give you basically two signals, okay? Now this is going to be your H1 and this is your H2. So two signals from here, okay? H1 and H2. So if this is your molecule, right, this is your H1 and H2. So can I say these two signals will also be H1 and H2? Why? Can anyone tell me why these signals will be H1 and H2? Anyone? So these signals will be H1, H2, or will they give you different peak? Right, okay. See, if we have to check the relationship of this carbon and this carbon, okay, if you have to check the relationship of this carbon and this carbon, so what we have to actually do, we have to find the relationship of this carbon and this carbon. You're getting the point? We have to find the relationship of this carbon and this carbon. If these two carbons would be identical, or if they would be homotopic, then these two hydrogens will also be homotopic, right? Or basically they will give you equivalent carbon positions. Okay, are you getting the point? So we have to check the relationship of these two carbons, then only we can predict relationship of these two carbons. Is it clear? Is this statement clear? We have to check relationship of these two carbons, then only we can predict relationship of these two carbons. Okay, so first thing is we need to find out the relationship of these two carbons. Okay, so see, if this is your molecule, a six-membered ring, so this is above the plane and this is below the plane. Okay, methyl and methyl. So now can I say that there is C2 axis over here? Can I say this thing, there is C2 axis in this molecule, right? So there is C2 axis in this molecule. Okay, now if there is C2 axis, so what can I say, that this carbon, this methyl and this methyl, they are homotopic? Can I say this thing, this methyl and this methyl are homotopic? Okay, or what can I say, that this hydrogen which is below the plane, right, and this hydrogen which is above the plane, they are also homotopic, right? So green hydrogens are homotopic, green hydrogens are homotopic, right? Okay, so now these two carbons are basically equivalent position. Okay, so now what can I say, that this hydrogen, this will give you one peak, this will give you second peak, but this hydrogen is equivalent to this H1 hydrogen, and this hydrogen is equivalent to this H2 hydrogen. Okay, so they will give you basically two peaks, 1 2, right, and this will be same as that of this H1 peak, and this H2 will be same as that of your H2 peak. Now let's go to the next two carbons. Okay, so now we have two more carbons, so we have just found that relationship of two carbons. Okay, so how many peaks? This will give you one peak, H2, right? This hydrogen which is below the plane, okay, this methyl is above, this hydrogen is below, this will give you H3 peak, and this methyl is below, this hydrogen is above, this will give you H3 peak only, right? Because these are homotopic hydrogens. Okay, now this will also give you H1 peak and H2 peak. Next thing is this carbon and this carbon. Now can I say these two carbons are also same, right, or they are equivalent, right? Because this carbon and this carbon is equivalent, this carbon and this carbon is equivalent. Okay, so there is a plane of symmetry passing through over here. There's a right C2 axis, so this half and this half is basically equivalent. Yes or no? Is it clear to all of you? This half and this half are basically equivalent. Okay, so this carbon and this carbon is equivalent. So how many hydrogens now, how many different peaks? So this will give you H, right, 4 and H5. Okay, this will basically give you H4 and H5. Is this point clear to all of you? Any doubts? Right, okay, so this will give you basically H5, and this will give you H4 and H5. Is it clear? Right, okay, so how many peaks we got now? We got basically 5 peaks. Okay, so we have basically 5 peaks, and then we have two methyls over here. So can I say these two methyls are equivalent, or they are homotopic? Right, we just found out that these two methyls are homotopic, so they will give you one peak, right? They will give you one peak. Okay, so 5 hydrogens from your cyclohexane structure and one hydrogen from your methyl. So total how many hydrogens? 6 different peaks in NMR signals. Is it clear to all of you? Any doubts in this question? Clear everyone? Right, right. If you have any doubt, you can let me know. I'll repeat this question in N. Okay, so correct answer for this question is 6. So this molecule will give us 6 different peaks. Okay, Now let's go to the next one. Alright, so this is basically your reaction. This is your main reaction, okay? And this reaction is catalyzed by N2O5. So this is your main reaction, that is decomposition of ozone. This is catalyzed by N2O5. This is the mechanism given of this complex reaction. You have to find the correct answer. If this is a chair form, then definitely your answer would be different. Okay, then you have to consider ring flipping into, right, basically then you have to consider ring flipping case also, right? So that is your advanced level, so that is not required right now. Just you have to understand if the structure would be planar, then how many peaks you will be getting. Okay, so ring flipping will definitely give you different type of signals. Okay, we have to see a lot of things into consideration for ring flipping structure. Yes, everyone. So yes, definitely this will take some time, but you have 1 more minute for this question. Okay, try to complete this question in a minute. Okay, so C, and then we have B. All right. Okay, so let's try and solve this question. Okay, let's try and solve this question. So what is given to us? This reaction is given. Okay, this is basically our main reaction. This one. Okay, decomposition of O3. So decomposition of O3 is given. Just a second. Right. Okay. So decomposition of O3 is given. Okay. So we have this reaction DO3 will give you DO, right? Basically 3O2. So this is your main reaction. Okay. And one more information is given to us, and the information is this reaction is catalyzed by N2O5. Okay, this reaction is catalyzed by N2O5. So this reaction is given. Okay, now what we have to find out? We have to find out the correct order, correct option for rate of reaction. Okay, so this is 2O3 and 3O2. Okay, so how many steps are given? 4 steps are given. Okay, so for which step I would write the rate? For which step we have to write the rate of reaction? The rate law. For which step I have to write the rate law? For first, second, third, or fourth? Yes, okay. So when so many reaction steps are given, so we have to select the one which is having the product, right, amount. So now you can see that this is your reaction which is having product amount. Okay, 2NO3 K3, and we have 2NO2 and O2. Okay, so you can see O2 is your product, so we can select this reaction. Okay, we can select this particular reaction. Okay, so now how we are going to write down the rate of reaction? This is nothing but right, this is nothing but 2NO3. Okay, this is your reaction, so let's write down the rate of reaction. Rate of reaction is 2, right, we have to write down for this reaction, so that is K3 and NO3. Okay, that is basically K3 and NO3. So is it clear to all of you? Any doubt? So this is going to be a rate of reaction. Okay, now, or what we can do, we can actually write down the rate of reaction for this step also. Okay, we can write down the rate of reaction for this step also, because in this step you can see O3 is also given. Okay, O3 is also given. In this step O2 is given, in this step O3 is there. Okay, so what we can actually do, we can write down this rate for this reaction also. Okay, so we can just select any of these two reactions and we can write down the rate. Okay, now let's go to this reaction. So we have this NO3. Okay, now we have to apply SSA on NO3. Okay, what we have to apply? We have to apply SSA on NO3. Okay, so let's go to this question now. SSA on NO3. We have to apply steady state approximation on NO3 concentration. Okay, so NO3 is present in the first reaction, so that would be K1N2O5. Okay, so first is what we are doing, we are actually writing dNO3 by dt. Okay, so it is present in first case, so it's K1N2O5. Okay, it's K1 N2O5. Okay, now this is your K1 N2O5. Now let's go to the next case. This is K1 N2O5. So next is NO3 is present over here, right? So that is K2 N2 NO2O3. Okay, that is K2 plus K2 NO2, right, O3. Right, this is your K2, NO2 and O3. Okay, next is NO2 is present over here in this reaction, that is third one. So in third one also NO2 is present. Okay, so what we can actually write down, we can write down this is NO2 and O3, we can write down K3 NO3 whole twice. Okay, whole square. So this is K3. Okay, basically 2 K3, then we have NO3. So is it clear to all of you? Are you getting the point? Right, are you getting this particular reaction? So this way you can actually calculate. Okay, or what we can do, see, you can see there are so many equations coming in this reaction. Okay, there are so many terms coming in this reaction, so we can actually write down. Okay, we can actually write down for your first step. Okay, let's go with first step, that would make this question right simple. Okay, so you have to select this thing. So you have two reactions, and in second step you have O3, so you can go with O3 also. Right, you can go with O3 also. So let's write down for second step. Okay, so we are writing this for second step. Right, so for second step rate would be KNO2 and O3. Can I write this thing? Yes, everyone. Yes, definitely, that would be whole square. Okay, that would be whole square. So can I write this thing? Rate is equals to KNO2 into O3. Right, can I write this rate for the second reaction? Is it clear to all of you? Can I write this rate for the second reaction? Okay, this is basically for a second reaction. Okay, so now what we have to do, we have to apply SSA on NO2. Okay, we have to apply SSA on NO2, and NO2 is present in first reaction. Okay, so we have to apply SSA on NO2. So dNO2 by dt is nothing but, right, K1 N2O5. K1 N2O5. Okay, this is for first reaction, and for second reaction it's minus K2 NO2 O3. Okay, this is for second reaction, and for third reaction basically it's, right, you have NO2 in product, so it's plus. Okay, it's basically plus, then we have 2K3 NO2. Okay, then we have 2K3 NO2. Is it clear to all of you? Then we have 2K3 NO2, right? See how we can write this reaction, right? If we have to write this reaction for right, theoretical rate, so this would be like this. So we can write 1 by 2. Okay, minus 1 by 2 basically dNO2 by dt. Okay, so this would be 2, there would be no whole square. Okay, there would be no whole square, because all these reactions we are finding out your order of reaction. Okay, so this is your reaction, so that is basically 2 NO3. Okay, we can write in this way, that is basically 2 NO3. Is it clear to all of you? Any doubts? Is it clear, everyone? Right, okay, so this is your K2 and this is K3. Okay, this is K2 and this is K3. Okay, so this is K2 and K3, so we can write K3, 2K3 and NO2, right, because NO2 is present in your product, so there is no negative, there is positive. Okay, so this is basically 2K3 and we have then NO3. Okay, NO2 basically NO3, so this is your NO3. Fine, let's go to the next reaction now. So in the next case NO2 is present in the reactant side, so this is minus KNO2 by NO3. Okay, it's minus K1 dash NO2 by NO3. So this is how we can write this rate of reaction. Okay, now what you can do, okay, see, we have this reaction, so N2O5 is in your reaction only. NO2 you have to apply steady state approximation. NO3 is also an intermediate, for this also you have to apply steady state approximation, and NO2 for this you have to apply steady state approximation. Okay, so what you actually have to do, this is your first reaction. Okay, now you have to apply steady state approximation on NO3 also. Okay, now you have to apply, right? Steady state approximation into NO2 also. Okay, right. So I'm getting your doubt. Basically, you are not clear with this aspect. 1 second, okay? 1 second. So we'll solve this question afterwards, okay? Because this will take some time. Let's complete all questions, then we'll solve this question, okay? I'll be explaining this question in detail, okay? So let's go to the next question first. Let's take this question first, then we'll again solve this question in the end. Okay, so the question is, if an electron has three spin values minus half, 0 and half, then what will be the maximum number of elements present in ninth period? Okay, so 75, 75, 75, and then we have 125. Okay, so what we have to do in this case, we have to see if this n is odd or even. Okay, so when we have n value, right, that is your period value, is basically odd. So which formula we have to apply? We have to apply n plus 1 divided by 2 whole square. Okay, for number of orbitals we have to apply n plus 1 divided by 2 whole square. Okay, when it's your even, so which formula we have to apply? N plus 2 divided by 2 whole square. Okay, so this is for number of orbitals when n is equals to odd, and this is number of orbitals when n is equals to even. Over here it's given 9, so which is your odd number. Okay, so ninth is your odd number, so n is equals to ninth. Okay, this is your odd number, so which formula we have to apply? We have to use this formula. Okay, 9 plus 1, 10, 10 divided by 2, that is your 5. Okay, 5 square is 25, so 25, right? Basically we have 25 subshells. Okay, we have 25 subshells. So now it's given that 3 spin values are allowed. Okay, so 3 spin values are allowed. So if we have 25 subshells, so into 3. Okay, so into 3, so 25 into 3 will be 75. So we can accommodate 75 elements, right, in ninth period. Is it clear to all of you? Any doubts? We can accommodate 75 elements in ninth period. All right, great. So let's go to the next one now. So this is your cell reaction given, okay, this is your cell given, and this is your E naught cell in terms of temperature, okay. E naught cell equation is given. You have to calculate standard entropy. You have to calculate standard entropy at 300 kelvins, and second is you have to calculate delta change in Cp. Yes, okay, it's T by Kelvin. Basically, this is your unit of temperature. Okay, it's nothing but temperature only. Okay, so what answer you're getting, all of you? Let's solve this question now. See what is given. This cell is given. Okay, basically this cell is given, and you have to calculate, right? You have to find the entropy change. Okay, so you have to find the entropy change. So the cell, what cell is given to you? Let's write down. So cell is platinum. Okay, cell is basically platinum is given, and then we have H2 HBr. Okay, so platinum is given, H2, HBr, then we have HBr and Ag. Okay. Yes, so this cell is given to us. Okay, so this cell is given to us, and what we have to find out, we have to find out entropy. Okay, we have to find out entropy. So what is your entropy when we are relating your thermodynamic parameters? Okay, so entropy is nothing but delta S is equals to NF. Okay, change in your E value divided by change in temperature at constant pressure. This is your value of entropy, right? Any doubts? Okay, so this is your value of entropy. Now what we have to find out, we have to find out this value. Okay, we know this is your constant value, Faraday's, and we have to find basically n value. Okay, so these two things we have to find out in this reaction. So for calculating your n value, we need to write down the reactions at anode and cathode. Okay, so let's write down the reactions at anode and cathode. So at anode, what you have? You have oxidation. Okay, so you have H2 gas. So definitely half H2 will give you H plus electron. Okay, and at cathode, what you have? You have AgBr. So AgBr plus electron will give you Ag plus Br minus. Okay, this is your reaction. So finally, what you will be getting? You will be getting half H2 plus AgBr. Okay, it will give you H plus Ag and Br minus. Okay, so this is your reaction. So this H plus and Br minus will combine together and they will form HBr and Ag, right? And in the reactant side, you have half H2 and plus AgBr. Okay, so finally your reaction is nothing but half H2 gas, okay, plus AgBr solid. It will give you Ag solid plus HBr aqueous. Okay, so this is your finalized reaction. Can I write this reaction? Is it clear how basically we got this reaction? So n is equals to 1. Okay, n is equals to 1 over here. Now what we have to calculate? We have to calculate the entropy change. Okay, we have to calculate the entropy change. Right. Okay, so let's calculate entropy change now. So let's go to this question. So what in this question we have been given with this value. Okay, so we have to calculate entropy change. So how we can calculate entropy change? We can use del E by del T at constant pressure. So basically we have to divide this equation with temperature. Okay, so this is your constant value, so this will give you 0. Okay, this value is minus 4.94 into 10 to the power minus 4. This is your temperature in kelvins, minus 298. Okay, this is your constant value. If I differentiate this value, so this will give you 1 value and this will give you 0 value. Okay, so this is nothing but minus 4.94 into 10 to the power minus 4 minus 3.45. So first I need to differentiate this part. Okay, so it is having basically whole square, so 2 into temperature minus 298. Okay, 2 into temperature minus 298, then I have to differentiate this brackets. Okay, so it will be nothing but 1. Okay, this will give you 1 value. So finalized equation over here is this equation. Is it clear to all of you? Any doubts? This is going to be your final equation. I hope you are getting this point. Okay, so now this is your value of del E by del T at constant pressure. Okay, now what we need to calculate? We need to calculate standard entropy change at 300 kelvins. That means I need to substitute this value over here, right? I need to substitute this 300 value over here. So now the answer would be 4.94 into 10 to the power minus 4 minus 3.45 into 2, 300 minus 298. Okay, or what we can write down, we can write just 2 in place of this expression. 300 minus 298 is nothing but 2. Okay, is basically 2. So now just calculate this value. You need to substitute this value. This is your this value over here. Okay, so now we have this value. So now we know what value you're getting over here. Calculate, everyone, just calculate this value. Okay, so you are getting minus 13.8. Okay, you are getting minus 13.8. So just now you have to put minus 13.8. So delta S is nothing 1 into F minus 13.8. So your change is minus 13.8 Faradays. Now you can just multiply this by 96500 and you will get the entropy change. Okay, so this is how you can calculate your entropy. Next, what you have to calculate, next thing is what you have to calculate, you have to calculate delta Cp. Okay, you have to calculate delta Cp. Okay, yes, okay, it's T by it's temperature by kelvins. Okay, they have just given you the units of kelvins. Okay, clear. Now let's go to calculating your delta Cp. So for delta Cp we need, what is the formula for delta Cp? Okay, so for delta Cp is nothing but nft. Okay, this is nothing but nft del E square double differentiation of your temperature value. Okay, this is going to be your delta Cp. All right, this is the formula of your delta Cp. So this is important, everyone just note down this formula. Delta Cp is nothing but nft del E square by del D square at constant pressure. Okay, now we need to substitute this value. So we got this value, right? We got this value. So this is your value of delta E by delta T. Now we need to double differentiate it. Okay, so this is your value. So this will give you 0 value now, and this will give you 1 value. Okay, so this is nothing but minus 3.45 into 2. So this is your value of del E square by del T square. Okay, so minus 3.45 into 2. This is your value, right? Okay, next is Faraday's is again 96500. Temperature is 300 and n is 1 over here. So you can just substitute all values and you'll be getting the correct answer. Okay, so is it clear, everyone? Clear? All right. Okay, so great. So this is how we can solve this question. Let's go to the next one now. Okay, so true statements for fourth order reaction. First statement says it can have value of rate constant, which is equals to 1 into 10 to the power minus 2 liter cube. Second statement, half-life is inversely proportional to A naught cube. Third statement, T half, right, is basically 5 by 3 A naught cube K. And D statement is none of these are correct statements. Okay, so B, B, BC, B and BC. All right, let's go with this question now. So let's use hit and trial method. Okay, so first statement says it can have value of your rate constant, which is equals to this value. Okay, so it's for fourth order reaction, so n is equals to 4. Okay, so what we can do in first case, we can actually check units of your rate constant. Okay, so how we can check rate unit of rate constant? So rate constant is nothing but K is equals to concentration 1 to the power 1 minus n second inverse. Okay, this is your formula for a rate constant. Now you can see if I put n is equals to 4, so we'll be getting some value of concentration. Okay, so that should have mole and liters. Okay, but over here we are not having any seconds and liters, mole value. Okay, so definitely this is your incorrect statement. Okay, option A is your incorrect statement. Now let's go to the next statement. Half life is directly proportional to a naught cube. Okay, now what is the relation of half life? So relation for half life is t half is nothing but 2 raised to the power n minus 1 divided minus 1, right? N minus 1 a naught to the power n minus 1 k. Okay, this is your relation of half life. So what can I say? That t half is inversely proportional to a naught to the power n minus 1. So n is equals to 4 over here, so 4 minus 1 is 3. Okay, so B statement is absolutely correct. Okay, let's go to the next statement. So t half is this value, so you can now calculate t half value. Okay, you just have to calculate basically t half value. How we can calculate this value? We know this is your equation. A is equals to n minus 1 is equals to, right, this is basically your equation. A is equals to 1 minus n, then we have a naught 1 minus n plus n minus 1 kt. Okay, this is your equation, and what you need to do, you just need to substitute this value over here. Okay, you can substitute this value, then you can use half over here, right? Or what you can do, you can actually use this equation also, which I have written over here, to n minus 1 n minus 1 k a naught to the power n minus 1. Okay, just you need to substitute these values and you can find out the correct answer. Okay, so n is equals to 4, you can solve through this equation. So what is the value of t half you are getting from this equation? Right, so you'll be getting somewhere around 7 by 3 a naught cube value. Okay, so this value is absolutely incorrect, right? This value is absolutely incorrect. So correct answer would be only option B. Is it correct? Okay, correct answer would be option B. Right, so now let's take the next question. I hope this is clear. Any doubts in the previous one? No, there is no need to consider bond exponent, because already they have mentioned in the equation, okay, which you have to use. So they have represented this equation of potential energy. You can use this equation to solve this question. All right, so let's solve this molecule. So we have calcium chloride. Okay, so calcium chloride is this geometry. Okay, we have calcium chloride and it's a linear molecule. So in the middle we have calcium ion, which is surrounded by two Cl negative ions in linear fashion. Okay, so this is your calcium chloride. Now what we can do over here, so let's solve this question. Okay, so we have calcium and then chloride and chloride. Okay, what is given to us, it's this value is given, right? Assuming that calcium chloride is a linear molecule of length 5.6 angstrom. So this length is given, that is 5.6 angstrom. Okay, this length is given to us. So definitely this length would be how much? This would be right, just 5.6 divided by 2. Okay, this value would be 5.6 divided by 2. This value would be 5.6 divided by 2. Okay, this is going to be your length of calcium and chloride. Okay, now what we need to do, we need to find out the potential energy, and they have already given one expression which we have to use in this equation. Okay, so that is 1389.4, that is 1389.4, right? Z1 Z2 divided by R. So this equation we have to use over here. Okay, 1389.4 Z1 Z2 by R in angstrom, and the answer would be in kilojoules per mole. Okay, so now let's substitute the values. So we have to take three cases. Okay, let's suppose this is calcium 1 and this is calcium 2. Okay, this is chlorine 1 and this is chlorine 2. So your potential energy would be potential energy of chlorine 1 and calcium plus potential energy of calcium and chlorine 2 plus potential energy of chlorine 1 and chlorine 2. Okay, so these are three different charges over here, and these are three possible conditions. Okay, so one is U is equals to this value. Okay, so Cl1 and calcium. So can I say Cl1 calcium and Cl2 calcium would be same? Okay, so I can write 2 into Cn1 calcium plus Cl1 Cl2, right? This way I can write down 2 into C1 calcium plus Cl1 calcium chlorine 2. Okay, so this value would be 2 into 1389.4. What is Z1? Z1 is minus 1, Z2 is minus 2, R, and R would be 5.6 divided by 2. This is your value. Okay, plus for Cl1 and Cl2, 2 into 1, right, this is not 2, only 1389.4 minus 1 into minus 1 divided by 5.6. Alright people, so this is how we have to solve it. Now just calculate this value and tell me the correct answer for potential energy. Right, okay, Z2 is plus 2, definitely Atanu. Okay, this is plus 2. Okay, great. So you're getting minus 1736 kilojoules per mole. Okay, so this is going to be your correct answer. Is it clear to all of you? Any doubts in this question? Is it clear, everyone? Clear? All right. Now let's go to the next one now. Okay, so this reaction is given. You need to find out the correct, right? The correct option. So you have different initial concentrations of NO and Cl2. Initial rate of formation of NaCl is also given. You need to find out the correct option. Yes, okay. If your answer is basically a negative, you have to give negative sign. Okay, you have to give negative sign if your answer is in negative. Okay, just read the question carefully. What actually they are asking. Okay, if they are using this term magnitude, so you just have to write down without signs. Okay, if they are not using this term and you are getting values in negative, so you have to write in negatives only. That you need to figure out, okay? That you have to figure out, Sripti, if it's MCQ or MSQ, right? Just see these options, just try to calculate the order of reaction. Third value is 3.75 into 10 to the power minus 2. This is your third value, okay? It's 3.75. And this is 0.30, okay? This is 0.30. Let me just read all the options. This is 0.10, 0.10, and the value is 5 into 10 to the power minus 4. 0.10, 0.50, 1.25 into 10 to the power minus 2. 0.30, 0.50, 3.75 into 10 to the power minus 2. So these are 6 values given. Yes, this is 0.30. Okay, Umesh, this is 0.30. Okay, so let's solve this question. See what we have to do in this question. We know what is experimental rate law. Experimental rate law is rate is equals to rate constant, concentration of A to the power X, which is your order of A, concentration of B to the power Y, which is your order of B. Okay, this experimental rate law we have to use over here. Now what we can do in this question, okay? So the trick for this question is just pick two right values having right one same value, okay? So you can see these are two given sets. In this set, NO value is same, okay? So we can actually cancel out this value, okay? So now rate would be 1.25 into 10 to the power minus 2 divided by 5 into 10 to the power minus 4, okay? This is your first, this two equation. So this and this would be cancelled out, so there is no need to actually write these values, okay? So this will be 1.1 by 0.5, so that is 1 by 5. 1 by 5 to the power y, okay? 1 by 5 to the power y. So basically this will give you 10 to the power 2, and this is 125 and 10 to the power 2 and divided by basically 5, okay? So you just have to use this equation and find out what is the value of y. Just calculate this thing, just calculate. Yes, everyone, just calculate this thing. It's very simple, okay? 1.25 into 10 to the power 2, that is 125 divided by 5. Okay, this way you can calculate this value and you have to find out the correct expression for your order of reaction. Right, okay. So you are getting y is equals to 2. Right, y is equals to 2. So this is your value, y is equals to 2. Okay, so the correct option A is definitely correct. Okay, reaction is second order with respect to chlorine. Okay, option A is definitely correct. Let's go to the next option, and option B says reaction is first order with respect to NO. Let's find out. So with respect to NO, so I'll be taking these two values. Okay, so R is equals to 3.75. Okay, 1.25 into 10 to the power minus 2 divided by 3.75 into 10 to the power minus 2. Okay, this would be 1 by 3x, and this value would be 1. Okay, because these two are cancelling out. So now you can actually find out the value, and you'll be getting x is equals to 1. Okay, you'll be getting x is equals to 1. Okay, so correct answer is also B. B is also correct option. Let's go to the next one now. Okay, let's go to the next one. So obviously if A is correct and B is correct, so option C is also correct. Okay, it's first order with respect to NO and it's second order with respect to chlorine. Okay, so A, B, C are going to be your correct options. Clear everyone? Any doubts? Okay, A, B and C are going to be your correct options. Great. Let's go to the next question. Right, okay. So fine. What is basically the geometry of your iron? In which type of unit cell iron crystallizes? Right, okay. So iron crystallizes in body centered cubic unit cell. What about copper? So copper crystallizes in face centered cubic cell. Okay. What about cobalt? So cobalt crystallizes in your which type of cell? HCP cell. Okay. And polonium, which is a very important case in this particular question. Okay, because it's the only that lattice which have SCC lattice. Okay, this crystallizes in your simple cubic lattice. It's a radioactive metal, so definitely it is very big in size and radioactive also. So it crystallizes in simple cubic unit cell. Alright, great. So let's go to the next one now. For the following consecutive reaction, A naught is 5 mole per liter. Find T max in seconds. Okay, you have to find T max in seconds. Ka is 0.4 second inverse and Kb is 0.1 second inverse. All right. So let's solve this question. So what we have to do, we have to find out the T max of consecutive reaction. So what is T max? T max is basically, right, we can write ln k2 by k1. Okay, this is your expression ln k2 by k1, right, raised to the power 1 by k2 minus k1. We can write this way, or we can write ln k1 by k2 raised to the power 1 by k1 minus k2. Okay, if you are writing k2 in numerator, so you have to write k2 minus k1. If you are writing k1 in numerator, you have to write k1 minus k2. Okay, just you need to now substitute the values over here. So this is ln point 1 by 0.4, right, divided 1 upon 0.1 minus 0.4. Okay, so this is how you can calculate this value. Okay, so I hope it's clear to all of you what answer you're getting after this calculation. 4.62, right? You're getting 4.62 after this calculation. What value you're getting after this calculation then? Okay, 4.62, right? Great. So let's go to the next one now. So we have one van der Waal gas. Okay, we have one van der Waal gas, and the critical pressure is mentioned, that is 90 atms. Okay, critical pressure is given 90 atms for this van der Waal gas. Okay, and we know in van der Waal gas, okay, in critical temperature value we have two constants. Okay, one is A and one is B. So only one constant is given over here. Okay, right, only one constant is given over here, that is 43 centimeter minus cube mole inverse. Okay, so what you have to calculate, you have to calculate critical temperature. Okay, you have to figure out if it's A or B. That's same. Okay, Tarunesh, that's same. If you multiply 1 by k2 minus k1 with ln k2 by k1, so this is nothing but your power only. Okay, we can write m ln x. Okay, so this is nothing but xm, so we can take this power before this term. You got the idea? So this is nothing but the same thing only, right? You can write that way, or you can go with this way. But that is outside the ln only, right? That is outside the ln only. Please don't get confused in this formula. See, the formula is ln k2 by k1. Okay, this raised to the power 1 by k2 minus k1, right? So I can take this value before this term, so that would be 1 by k2 minus k1 ln k2 by k1. Or what can I write? I can write ln k2 minus ln k1 divided by k2 minus k1. Okay, we can write in any way, this way, or this way. Just you have to remember one thing, if you are using k2 first, so in both the terms you'll be getting k2, right, in first place only. All right, okay. So for van der Waals gas, what is the expression for critical temperature? The expression is 8A by 27 RB, right? The expression is 8A by 27 RB. So this is your expression of critical temperature, okay? So we have been given with one constant only, that is 43 centimeter minus 3 mole inverse. So we have a volume factor over here, okay? Centimeter factor, mole inverse. So definitely this is your B value, right? Can I say this thing? This is your B value. So B value is given to us, okay? And we need to find out the critical temperature. So what is critical temperature? 8A by 27 RB. So we know R, we know B, 27. We just need to substitute the value of A. Okay, and one more value is given, that is critical pressure. What is the expression of critical pressure? Critical pressure is nothing but A by 27 B square, right? This is your expression of critical pressure. This is your value, this is your expression of critical pressure, A by 27 B square. Okay, now we can substitute this value over here. Okay, so TC is nothing but 8 and critical pressure is your this value. So pressure into 27 B square is your A value. Okay, so pressure into 27 B square is your critical, is your A value. Okay, 27 R and B value is given, that is 43. Okay, so this and this value will be cancelled out, 27 and 27 will be cancelled out. So in place of this PC we can write 90 over here. In place of PC we can write 90 over here. Okay, so I hope you got this idea. So this is your 27B square, this is 8A by 27 RB. Okay, this is 27 R and we have substituted the value of B. Okay, this is also B, this is also B. We can actually cancel out one B. Okay, so there is no need to substitute this over here. We can write B over here. So final expression is TC is nothing but 8 into 90 into B, that is 43 divided by R. Okay, what you need to do, you just need to substitute the value of R and you are writing it pressure in ATMs. Okay, so 0.0821. Now just calculate this temperature value. Yes everyone, so what is the temperature value that you are getting? Great. Okay, so the value will be close to 377.1 kelvins. Okay, the value will be close to 377.1 kelvins. Okay, so this is going to be your correct answer, 377.1 kelvins. Okay, approximately close to this value only. Great. Now let's go to the next one. Right, okay. So definitely you have to convert that value into liters, okay, and you have to use that particular value. Okay, what is liters? Liters is basically, right, your 1 centimeter cube is 1 ml. Okay, 1 centimeter cube is 1 ml, and you can now convert this ml to liters. Okay, yes, definitely. Right. Okay, 1 second. Yeah, so this would be cube only, right? This would be cube only. Okay, this small thing you can understand. Okay, basically this is the error over here. This is cube, right? Let's go to the next one. See, this is centimeter cube. You can convert centimeters to, right, ml, and you can now convert your to liters. Okay, so this is how you can do this conversion. Okay, is it clear? Right, you can do this conversion. Volume is nothing but 1 ml, and 1 ml is 1 centimeter cube, and you can now convert this ml to liters. Okay, see the value is see B value is 43 centimeter cube mole inverse. Okay, this is your value, and the expression we are getting this value. Okay, so we are dividing this by 0.0821 liter atm per Kelvin per mole. Okay, so we got liter terms over here, so we know that this is nothing but 43 ml. And how we can convert ml to liters? We can divide this by 1000. Okay, so this would be 43 divided by 1000 liters. Okay, now liter and liter would be cancelled, pressure term and atm would be cancelled, mole inverse and mole inverse would be cancelled, and you will be getting answer in kelvins, which is nothing but your critical temperature. Okay, which is nothing but your critical temperature. Is it clear? Is it clear now? Umesh, Atanu, everyone, is it clear? So you can do this conversion, right? If it's not clear, just let me know in the comment section. I'll solve each and every step of the question. Okay, so which of the following statements are correct? Semiconductors are of two types, N type and P type semiconductor. Is it correct or incorrect? This is your incorrect statement. Semiconductors are of two types, definitely, but not N or P. They are intrinsic and extrinsic. Okay, intrinsic semiconductors and extrinsic semiconductors. Okay, in extrinsic we have P type and N type semiconductor. Okay, so this is your incorrect statement. Right, this is your incorrect statement, first one. Okay, let's go to the next one. Semiconductor is a solid that conducts electricity without resistance. So definitely it is your correct statement. Next is, a semiconductor is a substance with a conductivity that increases as the temperature is raised. Definitely, if I'm increasing temperature or if I'm increasing the amount of doping, semiconductor conductivity will definitely increase. Okay, a metallic conductor is a substance with a conductivity that decreases as the temperature is raised. Is it correct? Yes, definitely. This statement is correct. In case of metallic conductors, okay, if I increase the temperature, so conductivity will be decreased. Okay, you'll be having less free electrons. So correct answer for this question would be option A. Okay, correct answer would be option A. Is it clear to all of you? Any doubts? Clear? Good one. Okay, let's go to the next one. So these are three values given of Miller, these are three values given of your intercept. You have to calculate Miller indices. The values are 2a minus 3b minus 3c. You have to calculate Miller indices. Right, okay, so what we'll be doing, we have to reciprocate this value, okay, 2a minus 3 minus 3. So V's indices would be 2 minus 3 minus 3. So we have to reciprocate this value. This is 1 by 3 or 1 by 3, minus and minus, okay. So if I multiply this value with 6, so this will be 3 minus 2 minus 2, okay. So correct Miller indices would be 3, 2 bar and 2 bar, okay. This is going to be your correct Miller indices. Is it clear, guys? Any doubts? Clear? I hope this question is clear to all of you, right? Okay, so that's all about all questions. Right, we have to discuss one question, right? So this is one left question. So let's complete this question also, okay. So let's complete this question also, everyone. Pay attention. What we have to find, we have to actually find the correct relation, okay. We have to find the correct relation. So let's go with this problem now. So I'll be writing right over here only. I'll be writing in this part only because it's very difficult to just turn the page right again and again. So I'll be writing over here only. If in case right the terms are not visible to you, just let me know in the comment section, okay. So what we have to do, we have to find the correct relation, and O2 is our product, so we can write a rate of reaction for this step, or O3 is our reactant, we can write it for this step. So we can go with any step reaction, okay. Let's write it with your third step because we have O2, okay. Let's write with O2. So what we can write down, we can write down, right, we are writing this for basically this step, okay, because we have O2. So rate is equals to K3, okay, rate is equals to K3. What actually we can write down, we have to write down the rate, okay, C. So what we can write down? We can write down rate. Rate is equals to K2, K2 NO2 and O3. Okay, we can write this way. Now we know NO2 is our intermediate, so we have to write down the steady state approximation for NO2. Okay, so how we can write down the steady state approximation for NO2? So d NO2 by dt is nothing but NO2 is present in first equation, so K1 N2O5. Okay, NO2 is present in your second equation. Okay, this is also NO2, this is also NO2. Okay, it's present in this equation two times. Okay, in your product also and in your reactant also. Okay, let me check the mechanism if it's right or not. Just a second. Okay, so the reaction, the reaction is correct only. So what we can write? See, in this case, this is NO2. If I'm writing for NO2, so that would be minus K2 NO2 O3. Okay, for NO2 that would be minus K2 NO2 O3. Okay, so again we have NO2 in the product side, so that would be plus K2 NO2 O3. Okay, so this term and this term will be cancelled out, so I can remove this term. I can remove this term. Okay, next term over here is what we can write down. We can write down for third reaction. Okay, so for third reaction it's in product side. Okay, if it's in product side, so we can actually write K3. Okay, it's K3, so we have K3. Okay, we have basically 2 K3, right? We can write 2 K3 NO3 whole square. Is it clear to all of you? We can write 2K3 NO3 whole square. Okay, then NO2 is again in the reactant side, so minus K1 dash NO2 NO3. Is it clear to all of you? Any doubts in this step? Just look at the screen, and if you have any doubt, do let me know in the comment section. Is it clear? Clear? Okay, great. So this is your step reaction. Now what we can do, we can see we have N2O5, we have NO2, and we have NO3. Okay, so we have to write it for NO3. We have to write for NO3. Okay, so for NO3, what would be the rate of reaction? For NO3, the reaction would be, let's go with first step. Okay, so this would be K1 N2O5. This would be K1 N2O5 for NO3, and for NO3 we have plus K2. Okay, K2 NO2 and O3. Okay, plus K2 NO2 O3 for NO3. Then we have NO3, so minus 2K3 NO3 whole square. Okay, then we have NO3 in the last step also, so minus K1 dash NO2 NO3. Is it clear? Any doubts in this step? Clear? Now what I'll be doing, so these are two reactions. Okay, this is first reaction, this is second reaction. Okay, now what I'll be doing, I'll add and subtract both these reactions. Okay, I can add and subtract both of these reactions. Okay, now if I'm adding both these reactions, so adding 1 and 2. Okay, so if I'm adding both of these reactions, so this is K1 N2O5, K1 N2O5, so this would be 2 K1 N2O5. Okay, next part is basically this is plus 2K3. Okay, this is nothing but plus 2K3. Once again, it's negative. I think it's positive. Okay, it's plus 2K3 NO3, it's minus, so this and this will be cancelled out. Okay, next we have K2 NO2 O3. Okay, so I'll write over here K2 NO2 O3. Okay, I'm writing K2 NO2 O3 over here, and this part will be cancelled out, K1 dash and K1 dash, so this would be minus 2K1 right dash NO2 and NO3. So is it clear to all of you? Any doubts in this step? Is it clear, everyone? Clear? Okay. Now next thing is I'll be subtracting both these equations. Okay. So 1 minus 2. Okay, 1 minus 2. So equation would be, I am subtracting both these equations. So this and this will be cancelled out. So now we will be left with 4k3. Okay, NO3 whole square, and this will be cancelled out. Okay, so these two equations will be cancelled out, minus k2 NO2 O3. Okay, we can do this way, we can just do this way, or what we can do, we can actually put this value to 0. Okay, or we can just go with this way also, we can actually put this value to 0. Okay, we can actually put this value to 0, and then we can substitute the value from here. Okay, then we can substitute the value from here. If I put this value equal to 0, so I'll be getting the expression in terms of NO2 and O3. Okay, then I can take right, then I can find out the value of NO3 from this expression, and I can substitute the value over here, right? So once I substitute this value in this equation, then I can find out the correct order of your rate. Okay, so just try this question now and tell me what answer you're getting for the correct, right, but basically what is your correct answer. You can ignore this step also. Okay, you can just go with, you can just equate this value to 0, then you can equate this value to 0, then you can actually right, put this value. See, in this term we have NO3 and we have NO2, in this term also we have NO3 and NO2, right? So it's very difficult for us to find out the value. Okay, it's very difficult for us to find out the value of NO2, so we can add and subtract both of these values. Okay, so that would be easier for us to find out the correct value. Okay, is it clear? Just add and subtract both these values, and then from that particular value you can find out the value of your NO3. Then you can substitute the NO3 value in equation 1, and then you can find out the then you can find out the your concentration for NO2, and then you can actually write this value over here. Okay, so this is how you can follow this step. Okay, so this is how you can solve this particular problem. Any doubts over here? Is it clear, everyone? Any doubts to anyone? Just try this right step and tell me what answer you're getting over here. Clear? Okay, so this way you can actually calculate. So now only in this class, just solve this question. Okay, and let's try to find the correct answer. Okay, so let's solve this question. So now we have added and subtracted both these equations. Okay, so when we are adding both these equations, so what we actually got, we got 2k1, okay, N2O5, and then we got 2k3. Okay, this and this will be cancelled out. Then we got plus k2 NO2, okay, O3, and then the next value is basically minus 2k1 dash NO2 NO3 when we have added these two equations. Okay, when we have subtracted these two equations, so I'm adding this and I'm subtracting this. Okay, so when we are subtracting this particular equation, what would be the correct answer? The correct answer would be, see, this and this will be cancelled out, and next is 2k3 plus 2k3. Okay, so this would be 4k3 NO3 whole square. Okay, this would be 4k3 NO3 whole square, and this value will be cancelled out. Okay, so now you'll be left with 4k3, okay, 4k3 NO3 whole square plus k2, right? This would be, yes, minus k2 NO2 O3. Okay, so this is going to be your answer. So this and this will be cancelled out. This is 2k3 and this is basically a plus 4k3 NO3, and then this is your minus k2 NO2 O3, and this will be cancelled out. Okay, now what you can do, see everyone, you can just substitute this value to 0. Okay, so let's substitute this value to 0. So this is nothing but 4k3 NO3, okay, whole square is minus k2, and then we have NO2. Okay, then what we have O3. Okay, now we are equating this value to 0. Now you can see that NO3 and NO2. Okay, we can actually calculate the value of NO3. Okay, so this is nothing but we have to calculate the value of NO3. So NO3 would be K2NO2 O3. Okay, K2NO2 O3 divided by 4K3, and this is a whole, right, basically a square. This is whole square, so this would be under root. Okay, so this is K2 half and this is 4K3 half, so this is 2 half and this would be half and half. Is this step clear to all of you? Any doubts? Is it clear? Any doubts to anyone? First let me know if this step is clear or not. Clear everyone? Okay, great. Next, what we have to do next is basically this is our step. Okay, next is this particular step. What we can actually do, we can substitute this value. So we know this value, right, and we know NO3 value. Now we can actually substitute this NO3 value over here. Okay, we can actually substitute this NO3 value in this particular equation. Okay, so what we have dNO2 by dt. Okay, this is nothing but we have K1N2O5. Okay, K1N2O5. Then we have plus 2K3. Okay, next is NO3 whole square. So we got the value of NO3 whole square. Okay, we got this particular value. So the value is basically NO3 whole square is K2NO2. Okay, divided by 4K3. This is your value of NO3 whole square. Okay, so minus K1 dash, and then we have NO2. Okay, then we have NO2, then we have NO3. Okay, so NO3 value is nothing but K2 half. Okay, this value is nothing but K2 half into NO2 half, right, divided by 2K3 half. Okay, so what you can do, just write all these values as K. Okay, so this is K1. Okay, N2O5, then this value would be K. Just let's write down K over here, 2K NO2. Okay, then this value is nothing but your K. Okay, so minus K value, so we have NO2 over here, NO2 half. Simple equation. Okay, now what we can do, this is NO2 N2O5, right, K1 N2O5 plus 2K NO2, and this would be minus K half, and 1 would be NO2 3 by 2. Okay, now we can just take this value as common and we can find out the value of NO2. So NO2 value would be, right, this is basically K1, this would be minus K1 N2O5. Okay, and now you can just take common of NO2 value and you can solve out the value of NO2. Then you can from here you can actually calculate the order of reaction. Okay, so just try this question again, right. I'll also try, I'll just write down each and every step after this class and I'll send you the solution is the group. Okay, and you can try this question also, you'll definitely get to the correct answer. Okay, so in this particular session, I hope you found this question useful, and if you have any doubts in this session you can let me know. I'll definitely make sure that again I'm going to repeat that particular question in the next session. Okay, so that is all about this particular class. I hope you found this questions useful and just try to solve this question. Okay, so in this particular case the slides are not clear. Okay, so I'll again try this question and write with basically a clear mind, and then I'll let you know the correct way of solving this question. Okay, great.